So, in this class I will explain infeasible solution in graphical method. So, we are discussing exceptional cases in graphical method. So, in this session I will explain infeasible solution. Infeasible, the name itself is the infeasible. The feasible solution does not exist. Feasible solution means what I will do, common part does not exist. So, if in the graph there exists no common part, then we can say that type of problems are infeasible solutions. Infeasible solutions. Okay, so I will explain. I will take one problem and then I will explain infeasible, how the common reason does not exist in the LPP. Okay, so let us solve the following LPP. Solve the following LPP by using graphical method. Solve the following LPP by using graphical method. Let us solve maximum z equal to maximum z equal to maximum z equal to 3x1 minus 2x2. 3x1 minus 2x2. 3x1 minus 2x2. Subject to the constraints. Subject to the constraints. Write down the first constraint x1 plus x2. x1 plus x2 less than or equal to 1. x1 plus x2 less than or equal to 1. Second constraint x1 plus x2. x1 plus x2 greater than or equal to 2. Greater than or equal to 2. How many decision variables are there? Two decision variables are there. What are they? x1, x2 greater than or equal to 0. x1, x2 greater than or equal to 0. Okay, now this is the problem. So only two decision variables are there. You can apply graphical method. So all of you know what are the steps in graphical method. Step number 1 is nothing but convert all the inequality constraints into equality constraints. Okay, right. Step number 1. Step number 1. Step number 1. Convert. Step number 1. Convert all the inequality type constraints into equality type constraints. Convert all the inequality type constraints into equality type constraints. Then we get x1 plus x2 equal to 1 and x1 plus x2 equal to 2. Next, what you have to do? You have to plot these equations on the graph. So how will you plot? By identifying the points first. You know the points, ultimately you can draw the graph. Okay, so that means you have to identify the points. Okay. So step number 2. Step number 2 is nothing but what is step number 2? Plot each equation on the graph. Plot each equation on the graph as each one will geometrically represent a straight line. Okay. So for that you require points. Points means what is it? Consider equation 1. Consider equation 1. Put x1 equal to 0. Put x1 equal to 0. x1 0 is what is the value? x2 equal to 1. x2 equal to 1. So put x2 equal to 0. x2 equal to 0 is what is it? x1 equal to 1. x1 equal to 1. So what is the point we are getting? Point we are getting is 1, comma 1. First point we are getting is 1, comma 1. Similarly, I will identify the second. Second line is this is the second line. Put x1 0 first. Okay. Consider equation 2. Consider equation 2. Put x1 equal to 0. x1 0 means x2 equal to 2. Similarly, put x2 equal to 0. That means x1 equal to 2. That means what is the point we are getting? Point we are getting is 2, comma 2. Now I know 1, comma 1 is the first point, 2, comma 2 is the second point. Now I know the points, I can draw the graph now. So I know the point, just I am writing first point is 1, comma 1. Second point is 2, comma 2. Okay, so these are the points I am getting. I can draw the graph. I think all of you understood. So scale we have to take is 1, 2. Highest value is 2, so scale is up to 2. Draw the graph. X axis, y axis, x1 axis, x2 axis. this is or is it loop. So how many points are there? Only two. Is the maximum value 1, 2. This is 1 and this is 2. Okay. First point. What is the first point? 1, comma 1. Identify 1, comma 1. 1 is this one and 1 is x axis. So this is equation number 1, line 1. And second point. What is the second point? 2, comma 2. So this is 2. This is 2. 2, comma 2. So this is second. This is the second. Now step number 2 is completed. Step number 3 is nothing but you have to identify the feasibility or common reason. So first constraint is less than equal type or greater than equal type. Less than equal type. Less than equal means below the line is shaded. Greater than equal means above the line is shaded. So first constraint is first equation is less than equal type. Less than equal means below the region is shaded. But like this is the shaded region. Just put an arrow mark. The previous problem suggests I put an arrow mark like that. Otherwise you can like this. Okay. And then second constant. Second constant is greater than equal type. Greater than equal type means what is it? Above the line. Greater than is above the line. Above the line is like this. This is the shaded region. So this is the shaded region. This is the shaded like this. Okay. Now identify the common. Can you get the common part here? First one is this one. First line. This is the shaded region you got. And second one, this is the shaded region you got. There exists any common region between 1 and 2? So this type of solutions are called. This type of solutions are called infeasible solution. Infeasible solution. So step number 2, what you write? Step number 2 is completed. Step number 3, what you write? There exists. Right. Step number 2, there exists an infeasible solution to the given entity. There exists an infeasible solution. There exists an infeasible solution to the given LPP. There exists an infeasible solution to the given LPP as there exists no common region, as there exists no common path or common, as there exists no common region between the lines. No common region between the lines. Therefore, the given MPP has an infeasible solution. Therefore, the given MPP has an infeasible solution. Infeasible solution. So we have finished graphical method. So in graphical method, what are the different models I have told? So graphical method consists of only 6 steps. What is step number 1? Step number 1 is convert all the inequalities into equalities. Every inequality constraint should be converted as equality type constraint. What is step number 2? Plot each equation on the graph. That equation should be plotted on a graph. That is the second point. Third point is nothing but you have to identify the feasible region or common region. How will you identify if the constraint is less than or equal type? Below the line is shaded. Okay. If the constraint is greater than equal type, above the line is shaded, and identify the common part. That gives feasible solution. And next, feasible solution means you will get a feasible solution with the characters A, B, C, D like that. Okay. So step number 4 is nothing but you have to identify the corner points of the feasible region. The corner points of the feasible region. That is step number 4. Step number 5 is nothing but identify your objective function. Identify your objective function. Maximized given or minimized given, and substitute these corner points in the objective function. Substitute these corner points in the objective function. Then last step is nothing but identify your optimum solution. Okay? That means if your objective function is maximization, go for maximum value. If the objective function is minimization, go for minimum value. So in this I have told 6 models. 6 problems I have told. I will not say models. So I have told 6 problems. So first model, what I have told, first problem, what I have told, objective function is maximization, constraints are less than or equal to type. Second model, second problem, what I have told, objective function is minimization, constraints are greater than or equal to type. Third problem, what I have told, objective function is either maximization or minimization, constraints may be both less than or equal to as well as greater than, mix. Okay. That is the third problem. Fourth problems I have told, those are the exceptional cases. Exceptional cases, and some special cases in graphical method. Third one I have told infeasible solution. Alternative optimum solution means what? I think already we have discussed the problem. Alternate optimum solution means the same optimum value at more than one point you will get. Same answer, same optimum value. Okay, same final answer. Okay, or same optimum value at more than one point. And suppose maximum z equal to 200, you are getting at a single point. If you get the 200 answer at more than one more point also you are getting 200, then you can say that is an alternative optimum solution. That is what you mean by alternative optimum solution. If an LPP has an optimum solution at more than one point, then that type of solutions are called alternative optimum solutions. Second one, what I call unbounded solutions. Unbounded solutions means what? Unbounded solution already I told a problem. So what you understood by the problem, what is the unbounded solution? The objective function value increase indefinitely when the decision variables also increase indefinitely. Then such type of LPP has an unbounded solution. Okay? And then the last one, what is the last one I have told? Infeasible solution. What do you mean by infeasible solution? If an LPP has no feasible region, no common part, okay, no feasible region does not exist, then that type of LPP has which type of solution? Then that type of LPP has infeasible solutions. Infeasible means common region does not exist. So this is the end of graphical method. Now you can solve any problem. Any problem. If you want to solve in graphical method, I think already I have covered all the models. So you can solve any model, but basic 6 steps will be there. That 6 steps are important. Okay. So now what are the next methods? Next method simplex become two-phase. Already graphical method we are using. Why you require another methods? What is the drawback of this method? The main drawback of this method is graphical method is used only for two decision variables. But whenever in the problem, if you have x1, x2 or xy, two decision variables are there, then you can solve that particular problem by using graphical method. Sometimes what happens is in the problem, three decision variables will be there. Three decision variables will be given, four decision variables will be given. Then you cannot solve by using graphical method. That's why the next methods are there. What is the next method? Simplex method. So in the next session we will discuss about simplex method. Before going to the simplex method, you have to learn the definitions of slack variables, surplus variables, and artificial variables. So simplex method means ordinary simplex method. Ordinary simplex method means objective function maximization or minimization. All the constraints are only less than equal to. That is called ordinary simplex method. Ordinary simplex method, all stack solutions we will come. So that means what is that? So first model is we will find out, we will give objective function is either maximization or minimization. Constraints are only less than equal to. So we will use ordinary simplex method. So why we require BKM and two-phase method? Sometimes what happens is the constraints may be greater than equal to or equal to. So if all constraints are less than equal to, then we will go for simplex method, ordinary simplex method. So if any one constraint is greater than equal to or equal to, you require BKM or two-phase. Any one method is required, BKM method, or you can use two-phase method for that. And if any one constraint is greater than equal to or equal to. So that's why the three methods are important. So whenever more than two decision variables are there, that can be solved by using simplex method. If two decision variables are there, then it can be solved by using simplex method also. Okay, so two decision variables you can solve by using graphical method. More than two is there, you cannot apply graphical method. That's why you require the next methods. That is simplex method. Simplex method is used, ordinary simplex method is used only for less than equal type constraints. If any one constraint is greater than equal type or equal type, require BKM method or two-phase method. So in the next session, I will tell you about simplex method. Okay, thank you.